In order to exactly calculate the instantaneous rate of change, or slope of the tangent, we can use the formula, the limit as h approaches 0, of f at x plus h minus f at x all over h. Let's use that formula in order to calculate the instantaneous rate of change of 3x squared minus 2x plus 1 at x is equal to 1. So we're going to use the formula that IROC is equal to the limit as h approaches 0 of f at x plus h minus f at x all over h. To use this formula, we need to know what f at x is and f at x plus h is. Well, f at x is easy. It's given to us. It's 3x squared minus 2x plus 1. F at x plus h is a little bit more complicated. How do we find f at x plus h? We take x plus h and we sub it in for every value of x using brackets. So we get 3x plus h squared minus 2x plus h plus 1. Before subbing it into the formula, let's simplify here. So we get, how do you square a binomial? You get 3 times x squared, you square the first, you double the product, and you square the last. Minus 2 distributed on here is pretty easy. It's just minus 2x minus 2h, and then plus 1. We'll expand one more time. We'll get 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 1. It's a lot easier to expand and simplify here than over here, where we'll have to recopy the line over and over again. Now that we have an expression for f at x plus h and f at x, we'll be able to sub it in. So we'll get the limit as h approaches 0 of 3x squared plus 6xh plus 3h squared minus 2x minus 2h plus 1 minus f at x, 3x squared minus 2x plus 1, all over h. To simplify this expression, we can subtract the two expressions, or polynomials. 3x squared minus 3x squared is gone. Negative 2x minus negative 2x is like plus 2x. Those cancel out as well. And then 1 minus 1 cancels out, because this minus distributes on each term of this polynomial. That should always happen. You should get no expression except for one with just h in it. Because what's the goal when we're evaluating limits of an indeterminate form? It's to cancel out the h. So now that we have all the expressions without an h gone, we can factor out an h from the remaining terms. We get, if we common factor out an h, we're left with 6x from the first term, 3h from the second term, and minus 2 from the third term. And that's all over h. Now that we've factored it out, we can cancel out the h's, leaving us with the limit as h approaches 0 of 6x minus 2 plus 3h. To finish off the limit, we sub in. We sub in for h here. We sub 0 in for h here, not for x, because it says h approaches 0. When you sub in, you get the expression 6x minus 2. This gives us the formula to calculate the slope of the tangent at every point on the curve f at x is equal to 3x squared minus 2x plus 1. Which one do we want? We want the one at 1. So we're going to evaluate the slope of the tangent at x is equal to 1. When you sub in 1 here, you get 6 times 1 minus 2, and that's, of course, 4. So the slope of the tangent at x is equal to 1 of f at x is 4.